Yesterday, do a quick little review of what we talked about. We talked about the coordinate system, the XY plane, the Cartesian coordinate system, Cartesian plane, um, and we talked about how to graph them, how to graph a function. Or well, no, we weren't talking about functions. We're talking about equations. So we were talking about how to graph an equation, how to figure out what points from an equation. You know, the x and the y values. Plug those in, see if you get something true. How do you find a y value that goes with the x value? Plug in the x value, solve for y, vice versa for the you have a y value, you're trying to find the x. And we talked about graphing equations by picking some points and picking them intelligently. How many points do we need at least? Um, and what kind of points to pick using one negatives, positives, zero. You have to make sure it's in the domain of the variable though. I think I kind of brushed on that a little bit, but those domain restrictions still apply when we're doing these. So, oh, and we talked about the quadrants. So you remember it was, let me draw this out. Remember there's four quadrants. You got Q1, you got Q2, Q3, and Q4. And so we're going to be talking about that a little bit today. Um, one thing, let's just skip this. In this quadrant one, both X and Y are positive, right? In quadrant two, X is negative, but Y positive. In quadrant three, both of them are negative. X and Y are both negative. And in quadrant four, Y is negative and X is positive. So that's going to come into play a little bit today. Um, I just have to memorize it, but understanding that may help a little bit. Any questions on that? All right, so what we're talking about today is symmetry. Okay? Some people say that symmetry is how do you say it? The essence of beauty or something like that. Seeing things that are symmetrical is more appealing to the human eye. There's all kinds of theories on that stuff, but we're talking about it just in strict mathematical terms. And so when we're talking about symmetry, it means that there's a mirror image. It's a repeated pattern on both sides. Okay, and some of the symmetry is easy to imagine, um, and some of it's difficult. I would say there's three symmetries we're going to look at, and two of them are easy to imagine. The third one a little tougher, a little bit tougher. So that's what we're going to talk about today. And let's read through this stuff. So a graph is symmetric with respect to the x-axis if the graph lines up when folded along the x-axis or the graph has a mirrored image about the x-axis. What that means is if we look at this image right here, remember the horizontal axis, that's our x-axis. If there's a mirror image below the x-axis and above the x-axis, that is symmetric with respect to the x-axis. The other way to imagine it, and this is how I've always done it, is if I folded that plane along the x-axis with this curve, match that curve. And in this case, it would. Now, they don't always have to touch. You see how these kind of collide here? That's not always the case. I mean, you could have I'm not the best artist in the world, but it's decent. You can have graphs where they don't touch. And so notice that this curve is a mirror image of this curve. So that would also be symmetric with respect to the x. Any questions on that? No? So what we're going to do is learn how to notice if a graph is symmetric, and we're going to learn how to draw part of a graph that would be symmetric to the different axes and the origin. That's last. So one thing to notice is if the point x comma y is on the graph, then the correlating point of x negative y must also be on the graph. And if you think about it, the reason that is because whatever's up here has to have a mirror image down here, right? And so if you have a point here, the x is going to remain the same, but you need a different y. Because y is positive up here, y is negative. Same thing in quadrant 2 and 3. Which we can look at example a little bit. Any questions on that? Okay, so watch. If you have a point on your graph, let's say that's 2, 3. If we want to graph it so this is symmetric with respect to the x-axis. This is our x-axis right here. What point would need to be on there as well? 2, -3. And we know that because it needs to be down here, right? We don't want to mirror it here. We don't want to mirror it here. We want to mirror it down here. And so we have a point right here, which is going to be 2, -3. That is where that note is coming from. If x, y is on the graph, and x, -y must be on the graph. Any questions on that? We'll do one more like that. What if you start with the point -5, -4? What point would also need to be there for it to be symmetric with respect to the x-axis? -5, 4. Yep. Oh, I wrote the point where I need to draw it. Let's draw it first. And we know that because whatever x, y you have, there needs to be x, -y. So if we negate the -4, it's a positive. Good. I did draw it kind of high, but yeah, imagine. Any questions on that? So you can use that for your graph when you're looking to see if it's symmetric. So if you want to see what's symmetric to this, it has to have all those points, same x values, but with the negated y. And so that's one way we can test it. It's kind of a long way of doing it, but you can choose a few points, right? Because we couldn't test every possible point. There's infinite number of points in it. But we can choose a few points to make sure. Any questions on that? Looks like the next problem was setting that up, what I just talked about. So yeah, let's get to that. All right. Symmetric with respect to the y-axis. Notice the way that it's said. Symmetric with respect to the x-axis, symmetric with respect to the y-axis. Sometimes I'll say symmetric around the x-axis, symmetric around the y-axis, symmetric to the x-axis, symmetric to the y-axis. But the actual correct way of saying it would be symmetric with respect to. So that's one thing that I try to say it every time, but I always start shorthanding it when I'm talking. So the y-axis, remember, it's that vertical axis we have there. And so whatever we have to the right of it, we also need to have to the left of it. So graph is symmetric with respect to the y-axis if the graph lines up when folded along the y-axis. So if I fold it along the y-axis, this curve will match this curve here. If the graph, and the other thing to notice is that if you have x, y, this time you're not going to have x negative y, you're going to have negative x comma y, which you can see in the image here. So if you have the point, let's do one now. What's that? Say 2, -3. What other point do you need to be on that graph for it to be symmetric to the y-axis, or symmetric with respect to the y-axis? -2. Yeah. So just negate the x. Any questions on that? So x and y, those, I feel like those are pretty intrinsic. Like you can kind of just understand it, just because we understand like kind of the mirror image and folding of the graph. It's kind of something we can imagine fairly easily. What's hard to imagine is symmetric with respect to origin. So remember, the origin is that point where the two axes meet, where the x-axis and the y-axis meet. It's the point 0, 0, right? And so for something to be symmetric with respect to that, it's like there's a diagonal reflection. And the way that I like to explain it is kind of with a rotation. If you took Q1 and you rotate it around, does it match Q3? If you rotate Q2, does it match Q4? Do the diagonals match each other? And so if you took this curve right here and rotated it around, it would match this curve right here. If you take the nothingness in this quadrant, rotate it around, it matches the nothingness. So this graph right here will be symmetric with respect to the origin. Any questions on that? That's like the toughest one to understand. There's another way using folding, but I think it gets a little too convoluted. If somebody wants to, if they have a hard time with the rotation, let me know. I could talk to you about it, but it's just a little tough in my mind to picture it. Notice that if x comma y is on my graph, the point -x, -y is also going to be on my graph. So it negates both the values. That's what's moving it between Q1 and Q3, Q2, and Q4, is negating both the values. Any questions on that? So if you have Q1, let's see, -4, 5. If you have the point -4, 5, what other point needs to be there for it to be symmetric with respect to the origin? It has to be 4, -5, which would be over here. So notice how that corresponding point is in a diagonal quadrant. I drew that way weird. Should have a little closer. It's hard to gauge it. And then you blow it up. Any questions on that? Nope. All about that. Good deal. All right, so pretty easy to tell for graphs. We're going to look at some graphs later. It might get a little bit more difficult, but right now, let's talk about, well, how do we know if I asked you what symmetry does y equal x squared have? How do you know? It's tough. All right, we could graph it, and yeah, we can know. But there's some tests that we can use for all equations to try to determine what type of symmetry it has. And this is going to come back when we talk about functions. We're going to talk about what kind of symmetry do the functions have, because that tells us some information about the function as well. So for it to be symmetric with respect to the x-axis, think back to what we were talking about with the point. Remember we said that if it's symmetric with respect to the x-axis, that means that if xy exists, it also must have x comma -y, right? And so the test for the x-axis, what we're going to do is replace y with negative y in our equation. And then we're going to simplify it. If an equivalent equation results, the graph of the equation is symmetric to the x-axis. So let's talk about what that means. We'll come back to this problem here. But what if we have y squared is equal to x plus 7? And I want to see, is that symmetric with respect to the x-axis? What we're going to do, in our equation, we're going to take what y is, and we're going to replace that with negative y. So we're going to have negative y squared is equal to x plus 7. Notice it was y squared, so now it's negative y squared. That's why I group it in parentheses, so that the whole thing is being squared. Now, nothing's going to happen on the right-hand side, right? I mean, it's x plus 7. Nothing I can do with that. But can I evaluate negative y squared? If I square a number, if I square positive 2, what do I get? I get 4, right? If I square negative 2, what do I get? 4. So if I square a y, or I square a y squared, I'm always going to end up with what? Just y squared, right? So even though there's a negative in there, because it's raised to an even power, it's the same as having a positive there being raised to that power. And so what I end up with, well, any questions on that? So what I end up with is an equivalent function to what I started with. So that means, yes, this equation is symmetric with respect to the x-axis. Any questions on that? So that's what you're trying to find. You're trying to get to the same equation or an equivalent equation to what you started. If you can get there, then yeah, it's symmetric with respect to that axis. If not, then it's not. Any questions on that? So, as you might gather, to test for the y-axis, we're going to replace x with negative x. And we're going to do the same thing. We're going to try to evaluate it and get it to be an equivalent equation to what we start with. Let's see if we can. So let's try that. Let's try a couple with that. So let's try that original one I just did. So what was it? Y squared is equal to x plus 7. And so if we want to see if that's symmetric with respect to the y-axis, we're going to replace x with negative x. All occurrences of it, there's only one occurrence here, but if you do have an equation with multiple occurrences of the variable, replace all of them. And so we'll end up with y squared is equal to negative x plus 7. And what can we do with that? Not much, huh? It's just y squared is equal to negative x plus 7. Is this equation equivalent to my original? No, a negative x is not the equivalent to x there. And so no, this is not symmetric with respect to the y-axis. Any questions on that? Got another one. Everybody still popping down? Oh, wait a little while. All right. What about, I don't know, y squared is equal to x squared. That's fine. Is this symmetric with respect to the y-axis? So we're going to replace x with negative x. So y squared equal to negative x squared minus 5. And we can evaluate that. So this would be y squared is equal to negative x squared. We can evaluate that to just be what? X squared. And so is the equation we end up with here equivalent to that one there? Yes, it is. So this is symmetric with respect to the y-axis. Any questions on that? All right. And as you may expect from what we've been talking about, to see this equation is symmetric with respect to the origin, we're going to replace both. We're going to replace x by negative x, y by negative y, and then we're going to simplify and see if we get an equivalent equation again. So it's the same process, it's just we're replacing different things along the way. So let's use this one again. So we're going to replace both x and y by their negative counterparts. So we're going to have negative y squared is equal to negative x squared minus 5. And so what's going to happen? We square the negative y. We evaluate that. That's going to be y squared. We evaluate the negative x squared. That's going to be just x squared. And so the equation we end up with is equivalent to our original. So that equation, the graph of that equation, would be symmetric with respect to the origin. Notice that the negative 5 really doesn't do anything, right? It's just kind of doesn't really change. Any questions on that? I got one more. Let's see. Figure it out. No. So we can't do much of that. So let's use y equals x to the third. And let's don't want to do all three. No, why not? Let's do origin. I don't know if this is gonna give me enough room, but we'll see what happens. Okay, erase that. So we got this equation. Y is equal to x to the third. I want to know, is this symmetric with respect to the x-axis, y-axis, and or origin? How many people think it's symmetric with respect to the x-axis? Nobody? How many people think it's symmetric with respect to the y-axis? One person? No? No? How many people think it's symmetric with respect to the origin? Nobody again? Okay, let's see what happens. They're saying no on y. Or yeah? Yeah? No. It's fine, you don't have to commit. I was just curious of what people thought. All right, so we're going to do the x-axis, so we're going to replace what? The y with negative y, good. So we have negative y is equal to x to the third. Is there anything I can do with that? No, I mean, I can multiply both sides by negative 1 if I wanted to, and I end up with y is equal to negative x to the third, but that doesn't get me anywhere, right? So boom, boom. No, it's not symmetric with respect to x. And I really shouldn't put big crosses over my work. So it's not. Talk about the y-axis. What do we need to do there? We're going to replace the x. So we're going to have negative x to the third. Can we evaluate that at all? Yeah, I think. No. It's a good idea. Like, I know looking at anecdotal stuff doesn't really prove anything, but sometimes if you're having trouble thinking about it, think about if we take 2 to the third, what does that equal? 2 times 2 times 2 would be 8, right? If I do negative 2 to the third, what does that equal? A negative 8, right? If I do a negative 2 to the third, what does that equal? It's going to be 2 to the third, which is 8, and then we're going to have a negative tacked on times it, right? So that's going to also equal negative 8. So notice that this and this are basically the same. So I could rewrite this as y is equal to negative x to the third. Does that get me to an equivalent equation, though? Not in this case. So it's no to the y-axis as well. But that is a evaluation we can do. Simple. All right, let's talk about the origin. So what are we going to do to test the origin? We're going to replace both of them, right? So we have negative y is equal to negative x to the third. So once again, just like we did here, let's try to evaluate that negative x to the third. And so we'll end up with negative y is equal to negative x to the third. Anything I can do to evaluate that? To get it, remember where we want to get to. We want to get to this, right? Anything I can do to get this to this within the rules of algebra. Yeah, but divide both sides by negative 1, right? That the equal relationship will remain. I'm just going to have y is equal to x to the third, which that is equivalent to that. So the origin is yes. This is symmetric with respect to the origin. What that graph looks like, in case you're curious, I can draw it. It's something like that. So you can see how Q1 and Q3, how they kind of match each other. Q2 and Q4 match each other as well. Because this little bump here matches that bump, and this line, it's actually a curve there and there, match each other. So that's symmetric with respect to the origin. I kind of emphasize the curvature of that graph, but it's about what it's like. I think it's less curved. It may not even go into Q2 and Q4. Kind of just snakes like this one. Any questions on that? That's basically all you're doing. Just plugging in the values, substituting them in, and then trying to get it to an equivalent equation. Just use everything that you know how to use. The main thing is the exponents. Those tend to mess people up. The other one that tends to mess people up is this. Come on, give me a marker. Well, those end up being equivalent. You're saying, yeah. Why? Do you think so? Why do you think so? It's going to be a positive number, right? It's not necessarily going to equal just x. It's going to end up equaling the absolute value of x, right? Because the problem is, what if x to begin with was a negative number? Then you would negate it again, and that would make it positive. But then you take the absolute value, you'll get the number. So this is going to evaluate to this. So if you have a negative variable in an absolute value, you could just write it as the absolute value of that variable there. Now it has to be, let me make sure, yeah, it has to just be the variable by itself. You can't do, I'll do it in red so you know you can't do it. All right, if you do 1 minus, the absolute value of 1 minus x, that doesn't evaluate to be 1 plus x, right? Because this whole number is going to be totally different depending on what's in there. If x was 3, this would be negative 2, which then you take the absolute value would be 2. This would be now 4. So you can't do that. Don't do that. What was the question we had? Can we just put it as a plus or minus? Are you referring to this here? Like you're talking about taking this or this and writing it as y is equal to plus or, well, actually it would be the other way around, right? It would be plus or minus y is equal, sorry, it would be plus or minus y. Did it again, plus or minus y. Like I can't get my brain to do that. There we go. Is equal to x. I mean, you could write it like that, but I feel like that's more confusing than writing it as the, like that. Because remember, the plus or minus goes on the side opposite the absolute value. So it wouldn't be on the x, it would be on the y. But I mean, you could, I mean, it's equivalent. It's just a little confusing. Any other questions on anything? So I know absolute value always messes people up. That's why I wanted to talk about it. I don't know if there's any problems like that, honestly. Oh, it's blank. All right, so what I have is a few for y'all to try. Oh, whatever, get that out of the way. So we'll do 2 at a time, I think. How much time we got left? Oh, we got all day left. So give these 2 a shot. We're testing for symmetry, so that means you're testing for all 3. X-axis, Y-axis, origin. But order, if you do them, does not matter. You may start to pick up some ability to kind of recognize what they may be symmetric with respect to, just based off of how the structure of the equation is written. And that's fine. Just don't assume it every time. Sometimes there'll be a slight change, like a plus or minus 1, that'll throw it off. So give these a shot. I'll go over it. So we have to do 3 tests on each one, basically. All right, we have to do y-axis. It really doesn't matter what order you do them in either. I would probably do the origin last because then you kind of know what to do with them. But it doesn't really matter. I think we did x-axis first last time. I don't remember. But let's say we do them in this order. So the y-axis, x-axis, origin. So remember, y-axis, we're going to replace x with negative x, right? It's the opposite variable. So we're going to have y squared equal to negative x plus 36. Anything we can do there to make it an equivalent equation? We can multiply it by a negative, and then we're going to have a negative y squared and a minus 36. So, nope. Not symmetric with respect to the y-axis. Any questions on that part? X-axis, we're going to replace y with negative y. So we're going to have negative y squared equals x plus 36. And here we can evaluate the negative y squared, right? That's going to become y squared equal to x plus 36. That is equivalent to our original one. So that's going to be yes. It is symmetric with respect to the x-axis. Any questions on that? And the origin. Now we're going to replace both x with negative x and y with negative y. And so we're going to have negative y squared equal to negative x plus 36. And so we can evaluate this square, make this y squared, but it's going to equal negative x plus 36. Is that equivalent to our original? No, so it's not symmetric with respect to the order. Any questions on that? Yeah, that's the one I wanted to. Like, whoa, right, hold on. Okay. Look at the other one. So we got x squared plus y minus 1 is equal to 0. Let's say we do the y-axis first. We'll do the x-axis. What if I could just do this? Oh, that's a game change. I didn't know I could just write right after and it'll go away. It's almost easy. All right, so the y-axis, we're going to replace what? X with negative x. And so we're going to have negative x squared plus y minus 1 is equal to 0. That negative x squared, that's just going to evaluate to be x squared plus y minus 1 is equal to 0. This is equivalent to our original equation. So we're going to say, yes, it's symmetric to the y-axis. Any questions on that? Start with the x-axis. So remember, we're going to replace y, negative y. We have x squared plus negative y minus 1 is equal to 0. Can't really evaluate that too much. I mean, we could make it x squared minus y minus 1 is equal to 0. But this is still not equivalent to my original because of plus y minus y. I can try to move stuff around, multiply by negative, but you're still going to end up with some changes that are different. And so it's not symmetric with respect to the x-axis. Any questions on x-axis? Let's talk about the origin. So for the origin, we're going to replace x with negative x. We're going to replace y with negative y. So we're going to have negative x squared plus negative y minus 1 is equal to 0. And we can evaluate the negative x squared. We can make that just x squared, but that's going to be minus y instead of plus y. And so this equation is not equivalent to my original. So this is not symmetric with respect to the origin. Any questions on that? Yeah, let's do the next one first. So notice the results that we got, right? Not y-axis, yes to x-axis, not origin. Yes, y-axis, no to x-axis, no to origin. And let's So the second one here is pretty difficult. To give it a shot, and we'll go over it. The first one's kind of one I want to prove a point with. All right, so let's look at that first one. So once again, we'll do our y-axis, x-axis. And so let's look at the y-axis first. So we're going to replace what? X with negative x. And so we'll have 4 times negative x squared plus 9y squared equals 36. And we're going to have that negative x squared. That's just going to evaluate to be x squared. So we end up with 4x squared, 9y squared equals 36, which matches our original equation. So yes, it's going to be symmetric with respect to the y-axis. Any questions on that part? So look at the x-axis. We're going to replace y with negative y. And so we're going to have 4x squared plus 9 times y, negative y squared equal to 36. Same thing's going to happen here. We're going to evaluate that negative y squared. So we're going to have 4x squared plus 9y squared equal to 36. And once again, that's equivalent to our original function. So yeah, symmetric with respect to the x-axis. And we're going to go to the origin. And you probably figure out what's going to happen here because we're going to do the same thing again, but with both variables, right? So we're going to have 4 times negative x squared plus 9 times negative y squared equal to 36. And so that's going to end up being 4x squared plus 9y squared equal to 36, which that, again, matches our original equation. So it's going to be symmetric with respect to the origin. Okay. Any questions on that? No. So my question is there any relationship between it being symmetric with respect to the y-axis, x-axis, and origin? And we can think about it. So we're going to start in quadrant 1. You could do this for all the different quadrants, but it's just easier to start in quadrant 1, right? And let's just choose, I want to choose a point or just a letter. Let's just choose a point. Comma 3. We'll see if this works out. If not, we'll go back to variables. Okay, so for it to be symmetric with respect to the y-axis, which we've been doing in green, what other point needs to be there? Negative 2, 3, because we're going to negate the x value, right? For it to be symmetric to the x-axis, what point would also need to be there? 2, negative 3, yep. Now, if this was symmetric with respect to the y-axis, that gives us this point, right? And the x-axis, which from the original point gives us this one, we'd also have a mirror image of this one here, right? Which would put us here, which would give us the point, what, negative 2, negative 3. Notice when I drew that point, now I'm symmetric with respect to what? The origin as well, right? These diagonals match up. And so, if an equation is symmetric with respect to the y-axis and the x-axis, it's going to be symmetric with respect to the origin. If it's symmetric with respect to just one of them, so if it's just to the x-axis, then it's not definitely with respect, it's not going to be symmetric with respect to the origin unless it's symmetric with respect to the y-axis. So if it's either or, it's not going to be the origin. But if it's both, then it's going to be the origin. But the other thing that can happen, and this is why people usually get confused when they think about this a little too much, but I like to introduce it because it's interesting how it plays out, is it could be symmetric with respect to the origin, but not the other two, right? I could just have the point -2, 3. Sorry, that's it, right? -2, -3, and 2, 3, which will make it symmetric with respect to the origin, but not the y-axis or x-axis. So it's either origin and none, or origin and both the other two. That's the only way it's going to be. It could be x-axis, not y, not origin. It could be y-axis, not x, not origin. Those are fine too. But if it's origin, it's either all three or just origin. Okay, so you can kind of use that to check your work a little bit. If you get that it is symmetric to the origin and the y-axis, but not the x-axis, something went wrong. You need to check your work. Either this one's wrong, or this one's wrong, or this one of them is wrong. Really, you don't know at that point. So that is something you can use to check yourself if you remember it. The thing is, people kind of get confused with it, but I do like it. I just don't like memorizing stuff, but it is something that you can use to work it out. All right, so let's talk about this one here. So this one's a little bit difficult because this is what? You got a rational equation in there. Almost said function. All I do is talk about functions in my other classes. I come here, not talk about functions. All right, so the same thing happens. The only thing is we have two x terms in there, so we need to replace both of them whenever we replace x. So, well, that's going to happen for the y-axis. So we're going to replace x with negative x. So we're going to have y is equal to 4 times negative x squared over negative x squared plus 1. And then we're going to evaluate those negative x squared. That's going to be y is equal to 4x squared over x squared plus 1. And so you see that matches the original. And so, yeah, it's symmetric with respect to the y. Questions on that? Try the x-axis. We're going to replace y with negative y. And so we'll have negative y is equal to 4x squared over x squared plus 1. Not much we can do here. We can multiply both sides by negative, but that means there's going to be a negative in the numerator or the denominator of that fraction on the right-hand side. And so, no, it's not symmetric with respect to the x-axis. And from what we just learned, if it's y and not x, we know it's not the origin. We can test it, though, just to make sure. We want to check our work. Oops, we're not replacing x with y. And so we have what? Negative y is equal to 4 times negative x squared over negative x squared. Was it plus 1? Yeah, plus 1. And so this is going to be negative y is equal to 4x squared over x squared plus 1, which does not match our original equation. And so it's not symmetric with respect to the origin. Any questions on that? Okay, so there's I wanted to work one together, and then if we got time to do some graphs real quick, that's what we'll wrap up with. So, just because the graphs can get a little confusing if they're not touching each other for some reason. All right, so let's say we have the equation x divided by y equal to 9x cubed. And if you can understand this one, I feel like you'll be good for the moment. The last one is actually pretty difficult too, compared to some of the ones we'll see. So notice we have a rational part in this one too, but it's x over y. And just like the last one, actually the last one domain was freely open, but this one y can't be 0, right? So that's something we got to think about. But we're going to do the same thing. We want to test for the y-axis. We're going to replace x with negative x. So we're going to have negative x over y equal to 9 times negative x to the third. So look how things gonna happen here. Left-hand side, can't do anything with it right now. Let's simplify the right-hand side first. Let's rewrite negative x over y. At 9 times negative x to the third. Remember that we can rewrite the negative x, then raised to the third. We can rewrite that as just negative x to the third. So this is going to become negative 9 x to the third. All right. Any questions on that? How I'm getting the negative 9. Everybody understands it? Okay. Now, does this match my original? Can I zoom out real quick? Oh, it never lets me do that. There's like a shortcut to zoom out, but it never works. There we go. Does this match my original? Not right now. Is there anything I can do to get it there? What's that? Times -1, right? Both sides are negated. They're negative of what they need to be. And so if I multiply or divide by both sides by -1, if it doesn't get me there, I mean, we start back and try something new. But if it does get me there, then good. So this is going to be what? Just x over y is equal to 9 x to the third. Yeah, so that would match my original. So this is symmetric with respect to the y. Any questions on that? The reason I did this one is because it doesn't look like the other ones. So if you notice, the pattern is when the x was raised to an even power, right? That really kind of made it the y-axis. This one is actually equivalent to the x being raised to an even power because you got this one here and this one here. If you were to get the x's on both sides, on the same side, it would just be an x squared. But since I wrote them on different sides, you got an x to the third and an x to the 1. But since there's 2 of them, it cancels out basically. So that's what I wanted to show. I'm not going to do the x-axis and the origin unless someone wants to see it. It's going to be not symmetric with either of those. I just want you to see how, don't assume that since it's not even, that it will or won't be. Always work it out just to make sure. Any questions on that?
I have a question.
Let's look at some graphs. I got a few minutes. I'll put them right here. I think y'all understand that, so I'm not going to mess with that. This is what I want to do. I want to do 3 of these. So let me copy that to a new page. Nope. Yep. Okay, so I want to take these. How come the y is not negative? Oh, wrong button. Here. So if you multiply a fraction by -1, the negative ones will either go to the numerator or the denominator, not both, right? Because if you go to both, it's like you multiply it just by +1. So I just made it go to the negative x, which would make it just a positive x. It's like if you're multiplying -1 times -1/2, the negative is either going to go to just the numerator or the denominator. And so that's going to equal +1/2. It's the same situation. You got it? Cool. All right, what I want to do here is, I know it says we want to graph it so it's symmetric to the y-axis, but I want to try all 3. So we're going to do the y-axis first. And then we're going to try the x-axis and the origin. So we want to draw this so it's symmetric with respect to the y-axis. First thing you got to do, remember what the y-axis is the vertical, right? The next thing I do is remember what points also need to be there. Remember, y-axis means that we're replacing x with -x, right? So that means we're going to negate the x values. If I negate 0, negative 1, if I negate that x value, a negative 0 is still just 0. So that one is going to be its own point again. If I negate the x on 1, 0, it's going to be what? What is it going to be? Is what? You're going to change the sign on the x value, right? What's the x value there? The 1, so you're going to make it a negative 1. So we're going to have the point negative 1, 0. And then we have the point 2, 3. So that means we need to have the point on the other side as what? Negative 2, 3. And so that means our graph should do like that. Oh, I missed the 1. To be symmetric with respect to the y. Any questions on that? Okay, so it gets a little bit more difficult. We go to the next one. So let's say we want to do, we'll stick with red. The x-axis. Remember, the x-axis is this right here. Notice that the graph crosses across the x-axis. That's when it gets a little bit more difficult to think about. And that's what I want to do. So remember, we're going to replace y with the negative y. So if I have the point 0, negative 1, I also need to have the point what? 0, 1, right? I need to change the sign on that y value. So I need to have this point here. If I have the point 1, 0, if I negate the y value, what is it going to be? What's the y value on that point? It's 0, right? So if I negate that, I mean, it's still just 0. So we're going to just have that point again. And if I negate the y value on 2, 3, what is that going to be? 2, negative 3, which will be over here. And so that graph, oh, didn't curve it enough. It's going to look like that. So notice how the symmetry, it crosses each other. So if you folded it along here, that part of the curve is going to cross over and have that as well. That's when people tend to get confused. It's when it crosses over like that. Any questions on that? Oh, and the last one. Origin. Remember, we're going to replace x with negative x and y with negative y. So we're going to change the sign on both. So we have the point 0, negative 1. I'm going to have what? Or change the sign on the 0, it's still 0. Change the sign on the 1, it's, well, sorry, negative 1, it's 1. So I'm going to have the point 0, 1. We have 1, 0. So I'm going to change the sign on the x. That's going to give it negative 1. Change the sign to 0. Say 0. So I'm going to have the point negative 1, 0. And then I need to change the signs on both the x and y of 2, 3. So that's going to be negative 2, negative 3. And so this is going to look like this. Oh, that was really bad. Okay. Notice how the quadrants match up, the diagonal. This matches this, this matches this little curve right here, matches that little curve right here, this matches that right there.